Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 16th, 2025, which was just 2 days ago. The standout result is simple but powerful. By turning recurring reasoning steps into concise behaviors, the approach cuts reasoning tokens by up to 46% while matching or improving accuracy. The paper is titled Metacognitive Reuse, Turning Recurring LLM Reasoning into Concise Behaviors, and the implications for model training are quite significant. Beyond token savings, the framework enables self-improvement without parameter updates and produces student models that are both more accurate and more token efficient through behavior-conditioned fine-tuning. On X, posts highlight that recurring reasoning wastes tokens and praise concise behaviors for cutting token use while keeping or boosting accuracy, with one summary thread and a short explainer video. Engagement looks modest, roughly dozens of likes. Alright, the previous segment set the big picture. Figure 1 shows the full behavior pipeline on the left and the 3 usage modes on the right, which makes the flow very concrete. The left stack illustrates solve, reflect, and extract behaviors, producing a named instruction that goes into a handbook. The right panels depict behavior-conditioned inference, behavior-guided self-improvement, and behavior-conditioned fine-tuning, so the handbook either guides a student at test time or generates training data to internalize skills. Alright. Figure 2 spells out the 3 prompts that operationalize the pipeline, so the steps are concrete rather than abstract. The solution prompt elicits a full reasoning trace with a clearly marked final answer. The reflection prompt defines what a behavior is and asks for correctness checks plus missing behavior analysis. The behavior prompt then converts that reflection into named, single-line instructions in a structured list. Okay, the previous figure laid out the prompts broadly. Figure 3 shows the exact behavior-conditioned inference prompt, which frames behaviors as short skills and then injects a list of behavior name and instruction pairs before the problem. The template instructs the model to reference behaviors explicitly during reasoning and to present a boxed final answer. This structure makes reuse explicit, so the model spends fewer tokens rederiving steps and stays organized. So the previous figure detailed the prompt template. Figure 4 reports outcomes on the math set, plotting accuracy against average tokens for R1 Llama 70B and QN 332B. The behavior condition curves sit higher and leftward, which means similar or better accuracy, with fewer tokens at fixed budgets. The left panel shows R1 Llama 70B gaining efficiency, and the right panel shows a larger gap for QN 332B. The legend encodes token budgets, so points along each line reflect stricter limits. So the previous figure showed accuracy and token savings. Table 1 presents concrete reasoning snippets where the model explicitly cites short behaviors, which makes the steps crisp and reusable. The left column walks through counting with total outcomes and inclusion minus exclusion. The middle column applies reciprocal and estimate reasonableness to division. And the right column translates a word problem into equations. These examples clarify that named behaviors anchor multi-step thinking, so fewer tokens are spent rederiving basics. Wrapping up, 2 takeaways stand out. Turning recurring reasoning into short-named behaviors cuts tokens by roughly half while keeping or improving accuracy, and those behaviors can guide both self-improvement and fine-tuning so smaller students learn to reason. The broader implication is practical frugality in thinking. Reuse beats rederivation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.